As we get into this next unit on integrals, we're really going to focus on the integrals being the area between the curve and the x-axis, and we're going to kind of extend that idea. To get ready for that, I want to look at the distance in between curves. So in thinking about distance, I want you to think about how far is it from 10 to 20. Well, it's not that difficult of a question, and real instinctually, the answer to that is that it's 15. But more importantly, how do you figure that out? And what if it's, how far is it from -7 to, 348,000? And how far is it from x minus 7 to x squared plus 38? That's what we need to extend the idea to. So how do we get that 15? And when you break it down and you think about how you do that, you recognize that you have two numbers. You distinguish between those two numbers which number is the larger number and which number is the smaller number, and you say, well, 25 is bigger. And so I'm going to take 25 minus 10 to get that 15. Right? So we recognize what's bigger and we use subtraction. That's how we find distance, because we want to find the distance between these two curves. When I'm asking you to find h in terms of x, recognize that what I mean by h is the length of this line segment. And right now, the way that this whole situation is defined is kind of vague. I mean, if we look, we have two different curves. One looks like a parabola and the other one is a line. We do have how they're defined in terms of their equation, but I have no idea where this line segment is at all. So think about these 2 points, okay? And that these 2 points, each of them have an x-coordinate and a y-coordinate. For both of these ordered pairs, the x-coordinates are going to be in the same spot, but their y-coordinates are going to be what's different. So when we want to find out the length of h, what we really want to do is find out the distance from between those two y-coordinates. And we're going to find that distance the same way that we found the distance between 10 and 25. We're going to recognize which one is larger and use subtraction. Right? So when we want to find out what h is, we need to recognize which y-coordinate is going to be larger. And the way that points on the plane work is that if a point is above another point, that's the larger y-coordinate. And the point that's below would be the smaller y-coordinate. So we're going to take the y-coordinate that's on top. Right? And that y-coordinate is described as x squared plus 21. Then I'm going to subtract the smaller y-coordinate. And the one on the bottom is described as -x minus 7. Now we have an expression that we can simplify. X squared plus x, and then 21 minus -7 is plus 28. And now we know the length of h in terms of x. Another task that's going to be important for us is finding these points A and B, these points of intersection of two curves. And just as a reminder that if we want to find points of intersection, what we're really doing is solving a system. We have the line y equals x and the curve y equals 12 minus x squared. And that's the system we need to solve. So we can use substitution and say x is equal to 12 minus x squared. That's quadratic, so I'm going to get it equal to 0 by adding x squared over to the left side and subtracting 12. Then we can factor it and get that x is equal to -4 and x is equal to 3. Right? Now that, of course, is not a solution, because what we're supposed to find are 2 points, A and B. So to do that, we need to have our point A that has an x and a y coordinate and find our point B that has an x and a y coordinate. I know 2 x coordinates right now. One of them is -4 and one of them is +3. Looking at the graph that I have here, A is to the left, which means that it would have the smaller x coordinate, and B is to the right, so it would have the larger one. In order to find those y coordinates, we're going to take those values and plug them into either one of those curves. I like this one where y is equal to x. So the y coordinate is going to be the same as the x coordinate. And there are our 2 points, A and B. And we still want to find length. So here again, find h in terms of x. So h is this vertical distance. In order to find the length of that line segment or find the distance between those two curves, we look at those as being two ordered pairs having x coordinates and y coordinates. And for these 2 points, their x coordinates are the same as their y coordinates are different. So we are going to identify what's the larger one and then use subtraction. So for h, the larger curve is going to be the one that is on top. And if we follow that curve, we can see that the equation for it is going to be 12 minus x squared. Then we're going to subtract the smaller y coordinate, which, as an equation, is y equals x, so the y coordinate is x. Then we can simplify the expression. To change it up slightly, what if we want to find k in terms of y? All right, k is right here. Again, the endpoints of this line segment are both points with x coordinates and y coordinates. And now, instead of trying to find a vertical distance, we're trying to find a horizontal distance. For these 2 points, because that's a horizontal line segment, they both have the same y coordinate. It's their x coordinates that are going to be different. So what we want to do, in general, to find the length of k, is to take the bigger x coordinate and subtract off the smaller one. And do it all in terms of y. That means that when we're looking at our 2 equations, we're going to need both of them written in terms of y, which means solve for x. Now, that first equation, y equals x, is pretty much already done for us because if we solve it for x, x is equal to y. So it's the same thing, not a problem. It's the second equation. We need to solve that for x so that we can write it in terms of y. To do that, I'm going to add x squared to both sides and subtract the y from both sides. So x squared is equal to 12 minus y. To get rid of the squared, we're going to want to square root both sides. So x is equal to plus or minus the square root of 12 minus y. So let's go back to finding k. K is, remember, is going to be the bigger x coordinate minus the smaller x coordinate. So when we're talking about 2 points that are arranged horizontally, their y coordinates are the same, but the bigger x coordinate is going to be the one that's to the right. So we take the point that's to the right, check out what its x coordinate is in terms of y, and that is going to be just y. Then we're going to subtract off the smaller x coordinate. So the smaller point is the one that is on the parabola, which when we follow that curve brings us over to this equation, and we have 2 options to choose from. One of them is either the positive square root of 12 minus y, and the other one is the negative square root of 12 minus y. Well, which one do we choose? All right. Now, where the positive and negative come in is right here. If we were to take that parabola and cut it in half, the right side of that parabola is the positive square root of 12 minus y. The left-hand side of this parabola is going to be the negative square root of 12 minus y. And since the point that we're looking at is the left-hand side of this parabola, we want to subtract the negative square root of 12 minus y. Then we go ahead and simplify our expression, y plus the square root of 12 minus y, and we're done. So now let's find m in terms of y, m being this distance right here. Again, this is a horizontal distance, so to find that m, we want to take the larger x-coordinate and subtract the smaller x-coordinate. And when we're looking at these 2 endpoints, both of these endpoints are on the same curve, that curve being y equals 12 minus x squared. Remember that when we solved this equation for x, so that we wrote it in terms of y, we got that x was equal to positive or negative square root of 12 minus y. So we are able to look at this curve as the left side and a right side. So when we go back to finding m, we need the larger x coordinate, which is going to be the point that's on the right side. That is the positive square root of 12 minus y. Then we want to subtract off the smaller point. Since that point's on the left side of the parabola, that's going to be the negative square root of 12 minus y. So when we take square root of 12 minus y and subtract the negative square root of 12 minus y, we're really adding those same things together, and we have 2 of these square root 12 minus y's. Alright, so let's go through it all again one more time with something that looks a little intimidating, but we know how to do it. First of all, if we want to find points A, B, and C, all 3 of those are points of intersection. Right here, here, and here. To find those points, we're going to set up a system using y equals 2x cubed plus x squared plus 2, and y equals negative x squared plus 4x plus 2. To solve that, I'm going to take those right sides and set them equal to each other. And start solving. When we subtract 2 from both sides, those 2's cancel. I'm going to bring everything over to the left-hand side. So we'll have the 2x cubed. X squared plus the x squared from the other side leaves us with plus 2x squared. And then subtract the 4x, and here we are. We can factor out a 2x out of this thing, and we'll be left with x squared plus x minus 2, which is a quadratic that we can factor, into x plus 2, x minus 1. Now I can see my 3x coordinates are going to be 0, and negative 2, and 1. So, in referencing our 3 points, A, B, and C, those are all going to be ordered pairs, with A being the leftmost, B being the one in the middle, and C being the one on the right. So the leftmost x coordinate would be negative 2. The rightmost x coordinate would be positive 1, with 0 being the one in the middle. To find their corresponding y coordinates, all we have to do is take them and plug them into either one of these 2 equations. It really doesn't matter which one. I'll just take the top one. So that for negative 2, y is equal to 2 times negative 2 to the third plus negative 2 squared plus 2. And we get negative 10. So that's the y coordinate for A. Do it again with 0, and we'll have 2 times 0 cubed plus 0 squared plus 2 leaves us with 2. That's B's y coordinate. And then for C, do it one more time with 1. So 2 times 1 cubed plus 1 squared plus 2 is 5. So that's C's y coordinate. Next, let's find those distances between the curves. First, find h in terms of x. So h is this little line segment right here. Remember, we want to identify which is the larger one and then use subtraction. Since we're talking about a vertical distance, that means our x coordinates of the 2 endpoints are going to be the same, but their y coordinates are going to be different. So to find h, we want to take the larger y coordinate, which is the one on top, and if we follow the curve, there is our larger y coordinate, 2x cubed plus x squared plus 2. Then we want to subtract the smaller one, which of course would be the other equation, negative x squared plus 4x plus 2. And then simplify. X squared minus negative x squared is plus 2x squared. Then we'll subtract that 4x, and 2 minus 2 cancels. So this is how we can describe that vertical distance in terms of x. And now when we look at k, the vertical distance here, again, it's still a vertical distance, so we want to subtract y coordinates in terms of x. So we're going to take the larger y coordinate from the point that's on top. And now, because we're at a different section of this graph, it's the other equation that's the larger one, the negative x squared plus 4x plus 2. Then we'll subtract the smaller one, the 2x cubed plus x squared plus 2. Same thing's going to happen with those 2's, but when we simplify, we'll end up with negative 2x cubed minus 2x squared plus 4x. So really, it looks very much the same as the last one, just complete opposite because we switched the order of subtraction. Well, that's how you find the distance between two curves.